I don't own a car, even though I work at BMW. I come from Munich, and Munich is really congested, and the public transport is really good. And the second question, how many of you guys faced a breakdown while driving a car? All right, that's quite some number. Uh, Taking further, explaining you the scenario, how this could lead to, what do we do when there is a breakdown? We call roadside assistance or something like ADAC or something like this. And what do? They might arrive in a couple of hours. They might tow the car and take it to the dealer where the repairs are done. So what does this all lead to? Bad customer service, right? So this talk will be all about like how we are dealing with customer satisfaction and how quick are we here and what is this bringing to BMW? Because customer is our first phase where we talk to them. Myself, I'm Roshan Amasa, working as a lead data scientist and architect at BMW IT Group. Been advising different business departments on machine learning, NLP, and new technologies. Moving on. To give you a small idea about how BMW Group IT is divided into, BMW as whole has 120,000 people, but when it comes to IT, it is 5,000 people spread across 29 locations, 29 countries, and the biggest change we had recently is moving completely into 100% agile. This was a very, very necessary step for us to move into this direction because we moved completely our strategy from working on waterfall model to agile. That being said, completely changing our whole organization structure of IT, 230 projects into 230 products now, and we work with backlogs right now. So end of the day, end of the year, what we do is like we produce products. To give you a scale of how big data is helping us out here, we have around 1 billion requests coming out every day from 12 million cars from the connected drive backend, and this is the amount of data we are processing every day. This is the organization structure at where I work, that is the Center of Competence for AI and Big Data. As you can see, we have divided ourselves into multiple products, core being big data and platform, and then advanced analytics, and then the new technologies like NLP, blockchain, and so on. Regardless of the industries where we are working, we all know that we have been facing digital disruption. Can we make use of it by adapting to the new digital transformation is the big question right now. BMW started this 5 years back, the foundation being having a good digital platform, data platform. This is the core of our business because without data, we don't answer questions. We can do it in a short while, but this will not help anyone else. So that's why what we started to do is we started 5 years back to have one common data platform where all the silos systems that were there from past 100 years, we started to bring it to one common place, and then we started to have the next step, that is to have a holistic analytical approach on this. That is where we started to move from, to take more data-driven decisions, moving from information to knowledge and knowledge to AI. To give you a broad perspective of how the portfolio looks and how AI is playing a very key role in the whole BMW value chain, Thanks. Um, Autonomous or self-driving is just one part of it, where in R&D we are using AI. But when you see the complete portfolio where we are using AI is like very vast. Be it logistics, be it sales, be it after sales, we have like varied amount of AI technologies that's being used across the whole value chain. To give you an example, couple of examples here, when we are talking about procurement, this where lots and lots of text data that's been there. NLP is being the biggest player here. It's been in the last couple of years, we were able to read the contracts of the other third partners in such a way that even 100, we could scale it up to 100 people reading it at once at a time. Coming to production, there are use cases where you can see we are using AI in all the kind of quality checks. I have a couple of more examples based on this later in my talk. Let's go there. And when it comes to sales, we have from price optimization to which countries, which cars have been needs to be delivered, which color, which configuration, and so on. The biggest AI that's been used in the car is the intelligent personal assistant. I don't know how many guys drive a BMW here. Recently it's been nominated as the best intelligent personal assistant in the cars. Moving on to the example of the production use case where AI is being used. This changed the whole mindset of the people working in the production plant. Before, people were doing quality checks manually, and what AI brought us, like I was involved in this project 2 years back. We went with a couple of cameras. We went to the plant. We said we want to install a couple of cameras just to collect images so that we can train some deep learning models. And what ended up is over the time, 80% of the manual quality checks that's been happening at the plants at BMW has been replaced by AI. Small video where how AI is being used. You can see here, it's been used for all the quality checks. On the left side, you can see here the gap between the doors and the panels. It's been checked here. And on the right-hand side, you see all the parts that's been installed, configured inside the car is been right or not. So this is where deep learning is helping us. But the basis for this was data collection. And this is where we started like a couple of years back to collect enough data. So what is the 4 pillars which is driving us in AI or the digital transformation space? We promised ourselves at BMW saying, this should be the core values at BMW Group IT. And these are data first. Data has to be, no matter what it is, data has to be in the quality that is, has to be so that we can do data-driven decisions. We started with a chaos, like 5 years back. We started collecting data. There was no data stewardship. There was no data ownerships. But then we set ourselves saying, like, this is not going to work. We need to have data ownership. We need to have quality data. And then we moved back a couple of years ago and then again started our core values. And that is where this data first was being the driving force. And then AI first. That means Gartner has been predicting by 2020 or in the next couple of years, 30% of the products or the software products what we produce has AI built in it. That means there are enough teams which have AI, which have data scientists working closely in building products so that they can use data in customer satisfaction. And the third one, this was a big decision for BMW because Data privacy was the biggest issue in Germany, and we didn't want to move to cloud. And this all changed a couple of years back when we said, when we were working with the cloud companies, when they brought in like so much of trust, and even people started trusting cloud, that is when we started completely moving from on-premise platforms to cloud technologies. The reason being scalability, flexibility, and the technology, the landscape of toolset what cloud provides. And the last one is the API first. So no matter what we produce as products, the core concept of BMW IT has been API first. By doing so, what we are trying to achieve is we are having some, if there is an API built for any kind of products, that means we are also having some kind of quality of the products being built. That means somebody is using this product, you are responsible for this product, and no matter you produce or consume anything with this API, you are responsible for it. So there is automatic quality that's been maintained. So that is the fourth pillar. This is the use case where Renault also talked about it yesterday, and I was talking to the Renault team yesterday, and this is, we see that there is so much of synergies here that we can collaborate and solve, at least at the data science levels. This is the use case which is similar to the talk yesterday, but we have different goals than what Renault had. So coming to the use case, the scenario which I explained at the start of my talk, customer satisfaction and the quality has been the biggest asset of BMW so far, the brand value. Can we address these issues quickly? To addressing these issues quickly, what are the different types of data that we are collecting from the car? The first and obvious one is the key readouts. That is, once you visit a dealer, there is a key that has been read, and then all the data has been is being transformed to the BMW backend. This is like almost like 90% of the cars has this facility, so we are good with the data here. But what is the frequency of the dealer visits? It could be like once a year, twice a year, or in case of problems, it could be like multiple times, not more than 10 or something like this. So the second type of data, what we are collecting is the teleservice data. That is this TSR data. The frequency of the data, what we get is weekly basis, or it could be bi-weekly basis. So the number of people who have opted out for this kind of service inside the car, anyone who's using this service or buying a BMW has to give us a consent saying that they're okay to collect this kind of information. So the amount, the BMW cars, out of 44 million cars, there are 10 million cars which has this facility, and out of this, like only just 4% of the people have been agreed to get this kind of data. So you can also imagine the frequency of data is not really, really good enough. And the third, the most important and the interesting data set is the crowd data collector. This is, the new cars have this facility. Maybe your car has this one. So the moment you start your car, and then you stop your car, the data has been constantly sent back to the BMW systems. And what kind of data we are talking about? It's not any personal information. It's not about the characteristics of you driving the car or something, but it's more or less what is the outside temperature, at what speeds you were driving at one particular time of, and so on. And the last data set is the last state call. This is also very similar to the crowd data collector. And these are the basic data that BMW is collecting from the car backend. So what is this use case about? Let me talk about the problem statement. As you can see here, when there was a breakdown, the car is being towed to the dealer. Once the dealer gets the car, he first does the key readouts. And then from then onwards, he started to fix the issues in the car. Until 36 days, until the warranty is being claimed for this one, BMW as a AG doesn't have this information about the breakdown. That means dealers, it's a tricky situation where in Germany where dealers are like little bit separated from the company as such. This has been the biggest problem, but we are also working towards it. And so there is a 36-day time period that we are not getting the information on time. So what does this lead to? This leads to a lot of warranty costs. This leads to the dealer, without knowing, could throw away the defected part. We can't do the right quality checks on time. So this was the problem that we were facing. And so what we did was, by bringing AI into this, we could track down or drop down this 36 days time period to 3 days. 3 days. That means once there is a breakdown of a car, he goes to the dealer. Once the readout is done, there are people sitting at the BMW AG where they constantly monitor the breakdowns. On the fly, they say, what was the problem? Is it a real breakdown or not a breakdown, or it was some kind of errors? And based on this, what they do is they send the team called as fault analysis team, where they can do the root cause analysis on this and then fix the issues very quickly. So what did the project was called Snoop. So what did Snoop bring to the table for the customer? For the customer, it was very obvious. If this was a common problem, there was a common solution to it, and the cars were fixed early, so the warranty period for sure reduced completely. And what did it bring for the dealer? More transparency. So there is no silos, dealers sitting and then working on one particular problem for days together. This brought in like complete set of transparency for multiple dealers. If it is the fault analysis team, this was the biggest asset what we achieved from this, is they were not getting the defected parts on time to do the root cause analysis. This was lacking with the engineering team, so they could fix the problems quickly. And for the BMW AG as such, it brought down the warranty cost drastically. So how did we achieve this one? We had 3 AI models. One was breakdown classification to say if this was a real breakdown or not a breakdown. And then the most interesting one, we have Q Scout. They are called quality scouts sitting at AG, tracking down the breakdowns to see if it is the right one. These are the engineering team people, so they know what they're talking about. So this was very interesting for them. The breakdown classification was pretty straightforward. It was a classification model. The second one, the clustering, the Q Scouts wanted a better approach to handle this large amount of breakdowns or the readouts coming from the cars. So how did they do? They asked us, can we streamline this or group them into different sectors? Because Q Scouts were experts in one particular, some Q Scouts were experts in engine types, some Q Scouts were experts in, I don't know, maybe the drive terrains or drive systems as such. So they wanted to group them into different sections so that they can quickly address these issues. So that is when clustering came into picture. And then the most interesting one, for a BMW as a company, what is more interesting, more than the breakdown, is the first breakdown, which my training data has never seen it at all. So this is more interesting because they can address this issue, they can prioritize this one, then they can see this one if this issue is happening in the next weeks, if this is coming up again and again with the new cars, so they can address it quickly, and then the customer satisfaction is reached here. So going to the technical background about it, is the models we used was not a fancy deep learning models, because the structure of the data was pretty much clean. We tried a couple of methods, but the best one which suited us with the breakdown classification was the XGBoost. The interesting thing here is we built a system with AI as focus, and there are people in the front end, the Q scouts, who are looking at this. This is it's like a monitoring tool. What they wanted was not just a breakdown saying like, yes, it's a breakdown, or not like a binary classification. So what they wanted was, is there some more values which I can get from the models as such? Like saying, which ECUs have been affected by this one? Has this ECUs been seen before? Do we have the parts for this? There were like 50 different systems which were not used in AI, but for the Q scouts, they wanted to integrate with the whole quality chain of the data sets available at BMW. So what they wanted was also how well my model is doing, and what is the main driving factors for this kind of breakdown classification, what my model is saying. They wanted some kind of like model interpretability, the feature interpretability, and this we achieved by having, I don't know if you guys have heard about line values or Shapley values. This was also given out to the Q scouts with the model prediction. Coming to the clustering, it's a semi-supervised learning here. We didn't have any idea about the data. And then when we wanted to group, the Q scouts were very active here. They said, I would label your data, but I need initial clustering. So once the clustering was done, it's a dynamic clustering methods what we are using here. So at the end of the day, every Q scout says whether this belongs to this particular problem or not. So they're actually labeling the data. At the end of the day, what we do is we dynamically pick up the labels what they are giving us back, because these are the real assets. And then we again retrain the whole model with these new labels. And the last one, anomaly detection, we used a autoencoder where we can find the anomalies in the data. So the architecture behind it is we used before going into cloud, we were using. It's called deep learning platform inside BMW, where there is a construct of like multiple GPUs on it, and every model what we deploy is also an API first. So it was containerized. So every model was built as a REST API, and then there is a backend which is serving the data and calling this APIs to get the predictions. And then what we thought was like this is kind of working well. How can we do more frequent retrainings? Because the clustering algorithm, what we spoke about, wanted every hour retraining that needed to be happen. And this was not helping us. The online, the on-premise platform was not really suitable for this. So we had to choose one of the cloud leaders here, and Amazon really helped us out to scale this project in cloud. And what you can see is it's a very simple, straightforward architecture. Once we get the new data, it's been pushed to S3 buckets, and then there is a Lambda function which triggers this. And there is like the data what we are talking about is close to 80 GB to 100 GB. It's only what you're talking is 2 years data. We didn't wanted to touch the much older data here. And then we use SageMaker for our model training. And and what we did was like we had 3 different models. We pushed the images, we containerized, we pushed the images into the Amazon registry, container registry, and then at the end we serve the models with Fargate, which is completely serverless. All in all, the architecture looks like this at the end. The main advantage of going into cloud was having this model agnostic approach of model retraining. That was the biggest advantage what we could see here. Little more about AWS. What we could achieve with cloud is operational efficiency. All the components which you saw here is serverless. That means there is no person sitting behind to take care of some kind of components if there is a breakdown or something. The second biggest thing is like the whole chain from the data coming in until it's been served, it's completely automated with all the best CI/CD techniques. And what did it bring to us? Before we had a training time of around 4 hours. It brought this down completely to 1 hour, or even less in some models. And then the monitoring abilities what AWS is giving us out here. I would skip this part. This is more or less AWS serverless, fully managed services. So what was the success, what this AI brought to this Snoop project? As you can see here, once there is a breakdown, there is a Q scouts immediately receive this information. And what this Q scouts are doing is like, he says to the dealer, attention, I know the issue, this is the solution for it. Please raise a warranty request for this one. If there is some kind of interaction that needs to be done between the Q Scout and the dealer, this was also the chat was integrated with this system. So he could write, the Q Scout could ask the dealer to say, please mention more details about this breakdown. And there was also the parts logistics was also integrated with this system. That being said, that if there is a part that needs to be shipped to a dealer, the Q Scout can talk to different dealers and say, we have seen this problem with this dealer before. He has excess of parts for this breakdown. You could also get this part on time. That means the car need not be at the dealer for like weeks together. It could be reduced to a couple of days. And also the Q Scout has this facility saying like, this issue, we know this issue, we have our fault analysis team coming to you to fix this problem on the road. So this option was also given from this Snoop project as such. So how did we go from one-time analytics to building real products? So what we did was started to collect data, create data, and ask business department saying what kind of data we need for solving these problems. And then what we did was like we had like 50 different systems of data. We started to aggregate data, and then we started to build semantic layers on it, so that it's not one product the data is being used by one product, but what we are leveraging with AI and big data is like building once a semantic layer. There could be like hundreds of use cases that can be done on this one. And then we started analyzing, and then that's the last stage where we started to act on it. So the lessons learned is, I heard a couple of talks yesterday. People were not happy with the proof of concepts techniques, but from my experience, or at least from BMW experience, always go for fail fast approach. That means couple of weeks, sit with the business department, ask their problem what it is, get a small sample of data, try to fail fast. That means in 3 weeks or 2 weeks, you could already say if this is achievable or not. And then from then onwards, go start building products iteratively. Always work with business departments. That being said, you can do innovations endlessly, but if this innovation is not being used by the business as such, there is no real value that we bring across. Leverage the potential of cloud services. I always say this, BMW also says this, cloud-first strategy, make a conscious decision moving into cloud. If there are cases, if there are data privacy issues, then you can think of on-premise platforms. That's my last slide. There is a very nice book which I read a couple of weeks back, and this is the stats from that book. The book is called The Technology Fallacy, where Gerald Kane says the digital transformation is not about technology or AI that's happening exponentially. It's about the mindsets of people, mindsets of organization, and mindsets of regulatory boards which are there. So you can see from the stats, the gap between the technology that's been exponentially growing and the mindset of the individuals adapting to it is very less. But when you compare it with the organization, you see a huge gap. And then you can compare it with the regulatory boards and the policy boards. You see there is a huge gap. This is where we want to work, and then we have to close down the gap between these two. All right, thanks a lot.